Translate means move. No, right, move. Pick it up and move it, okay? Now, all of these transformations you can do with tracing paper, if it helps, right? But definitely rotation, but you can do them all with tracing paper if you want to. Now, what we're going to do here is we're going to move right or left, and then up or down. The top number will tell you if it's right or left, plus to the right, minus to the left. And the bottom number will tell you if it's up or down, plus for up, minus for down. So this would be 5 is 5 right, and minus 2 is 2 down. Okay, now I have put the question in here down the side in yours. How do you reverse this? How do you go backwards? Well, we'll talk about that in a minute, but let's do it first. Now, if you did it with tracing paper, you literally would trace the shape and move the tracing paper 5 squares over and then 2 squares down and draw it where it is. Okay, so you could do it with tracing paper. Alternatively, pick a corner and move it 1, 2, 3, 4, 5 squares over, 2 down. What are the mistakes that are made here? People think that this is something to do with a coordinate. People go down here for some reason. They kind of go, oh, down here, that's where 5 minus 2 is. No, doesn't matter. That's not a coordinate. That's a movement. 5 to the right, 2 down. Here is the new position. Then we can draw from here. We can see from this corner, we need to go 2 across, 3 down and back. 2 across, 3 down and back. Like I said, though, you'd be given tracing paper or ask for tracing paper, and you can just move your tracing paper. Okay? Now, there was a part B that says, what column vector, oh God, it's just a posh word for that. How would we reverse it? How would we go backwards? Well, we wouldn't go right and down. We'd want to go left and up. So instead of 5 to the right, we'd need 5 to the left. And instead of 2 down, we'd want to go 2 up. So we're just kind of taking the pluses and making the minuses and vice versa, I guess. Okay. And then you can have a go at the second one. Yeah, just have a look at this now. Think what these numbers mean. What does that minus 5 on top mean? Well, it's 5 to the left. What does minus 4 on the bottom mean? 4 down. Okay. Next page, if it comes. Okay. Alternatively, shape A is translated onto shape B. Which one of these is it, right? So pick a point and go, well, how do I get there? Well, to go from A to B, it's 1, 2, 3, 4, 5, etc., etc. So how many across, how many down, and try and find the numbers there that tie in with right and down with the correct numbers as well. Okay? Okay. Then we're on to our second one, rotate. This one I can't do on this one. We do need tracing paper. What we need to do is find the center of rotation. It'll say about the point. So minus 2. This time, this is a coordinate. Coordinates are written like that, right? Compared to what we just had, which was that. That was with a number here and here. That's a vector. That's a translation. This is a coordinate. Okay. We trace this onto our tracing paper. And we trace this point here. We put our pen on the tracing paper here and we turn our tracing paper either anti-clockwise or clockwise. Now in this case, it's going to turn anti-clockwise and it will end up being up here, I believe, but we've done this in class, so I don't want to speak anymore about it, okay? If it was clockwise, it would end up being, I believe, in this position here, but this is the one they want for that, okay? You can try it again. Again, I mentioned this in class, so I don't want to say too much, but the origin is just another word for 0, 0. So your cross here needs to go there. Then you can use your tracing paper and you're away to go. Okay, just like with the translation, the third one is describe it. So you'd have to go, right, okay, what's going on here? This is a rotation. I need a bit more information than that. Which way are we going? T to S? No. How do we transform triangle S onto, in fact, so we're starting at S and we go into T. In other words, this is anti-clockwise. Second mark, and it's 90 degrees. Okay? You could really show off, but I don't think you need to. I need to check the marking, but I don't think you need to. Generally, ladies and gents, that would, for the ones where you're describing them, that would be the center. You can kind of see to get to that point, it's kind of 3 up and 1 across, and to get to that point, there is 3 across. So that's the center. So you could really show off and say, I actually can give you the center as well, which is 0, 0, or use the word the origin. I got a funny feeling though that's the 3 marks. Okay, right. Reflection. Again, you can use tracing paper, but the most important thing is, do you know, can we now draw y equals 1? Do we realize that y equals 1 goes in a totally different direction to the y-axis? This is the y-axis. So the line y equals 1 or y equals 2 or 3 goes across. Again, too many people just moving it down. It's flipped, right? Use your tracing paper and flip the paper over. You'll see that what's there flips down to there, but what's there flips to there. What's there flips down to here, but right the way up here, which is 4 squares away from the line, flips all the way down 4 squares away. And actually, but use your tracing paper if you want and flip it over so you can see it. Okay? Again, another chance for you. Yeah, this time you aren't drawing a line, you're actually using the x-axis. So this time your line is one of the axes. It is this one, so we're flipping it down there, down here. Not moving it, flipping it. That's all right. The line x equals 1, which is that line there. X equals 1. So this time we're flipping it this way. And a fourth chance here where you've actually got to just get 2 marks. So again, what is the transformation this time? Well, you'd have to spot, well, this is a flip, but the word we use for flip is this is a reflection. And if it's a reflection, you need to be saying what the line is. Is it x equals something or y? Well, it looks like it's there. I'm not going to write it. You tell me what line is that, right? Okay. And finally, enlargement. Okay. Scale factor 3. 3 times as big. That'll get you 2 marks. Center, a bit like rotation, but this time center, 1, 2 there. This time, to get it in the right place, you need to draw it 3 times as big, but also 3 times as far away. So to get to the corner here, you can either go diagonally. It might be better to think of it as going across and up though. Over 1, up 1, right? That's, if I double that, I go over another one and up another one. If I triple it, I go over another one and up another one. So this is now 3 times as far away, over 3, up 3. I now need to draw it 3 times as big. So 1 across, 3 across. 2 up becomes 2, 4, and I'm running out of paper, but 6 up. I'm running out of room there. I can just quickly scan it up. Yeah, why not? And finish that off here. Okay. Whereas this one, lovely people, to end this little section, a scale factor of half, everybody assumes enlargement means make bigger. But actually, a scale factor of half means half the size of it, right? This time our center's here. So we want to half this. So instead of a 6x4 triangle, I want a 3x2, half the size. But I also want to go half as far away. So to get from there to there is 8 across and 2 down. Half of that would be 4 across and 1 down. That's halfway to there. And now we want it half the size. So it's half as big and half as far away compared to 3 times as big and 3 times as far away. Fabulous, I think. Right. Dimensions. I'm going to leave it. I'm going to come back to it. Right. Area and perimeter of shape. So perimeter is adding up all the way around. Area is times in. Now, for example, if it's a rectangle, length times width. If it's a square, length times width, but they'd be the same if it's a square, right? So the length and the width are the same. If it's a triangle, it's base times height, but we need to remember to divide our answer by 2. If it's a circle, it's pi times the radius squared. And the dodgy one, if it's a trapezium, you don't need to learn this, but you need to know where it is on your formula sheet, and you need to turn that and realize this is the only one that contains an add. Even though it's an area, it contains an add. It's the top, add the bottom, half the answer, and then times it by the height. Okay, here. Got to split this shape up into rectangles. It's the only way to do it. This rectangle here, length, width. Length times width. This rectangle here, length, not width. The 8 is all the way across, and I only want to there. Okay? But if we spot that that is 4. Right? Then this must also be 4 to make them add up to 8. So this one would be 12 times 4. Add them together. Here. Length times width. For the triangle, base times height, which is 6. Because if that's 9, 15 take away 9 means that that's 6. So base times height divided by 2. Okay, let's crack on. I got rid of those. I'm not going to say anything about that. Now, it does tell you this is a trapezium. It's also paper 2, so it's a calculator. It does tell you that. Now, a lot of people, though, like to split this, a trapezium that looks like this, they like to split it up into a rectangle and a triangle. Totally fine. If you've done it by splitting it up, totally fine. However, because it's a trapezium, the alternative to splitting it up is to use this, where it's a half. The top is 17.3. Add the bottom, 8.2. Work that out, add them together and half it, and then times that by the height. Okay, and you'll get the same answer doing that as you would by splitting them up into a rectangle and a triangle. Okie dokie. Yeah, a bit of working backwards here, isn't it? The area of the rectangle is 45. That's the area of the rectangle, so we don't know this. But 9 times whatever that is needs to answer 45. So we need to work out how many 9s go into 45, telling us that this is 5. Now, you can now work it either out as a big trapezium again, or what a lot of you have done and gone, look, in fact, actually you can't, because it doesn't say we want the area of the trapezium. It says we want the area just of the triangle bit. So we don't want the full area. So actually here we need to use base 6 times height 5 divided by 2. So we're going to use base times height divided by 2. It's OCW, so I'm going to need some bullet points. What are you doing? The length of the rectangle is, the area of the triangle is, also units. If we're talking about lengths, it'd be centimeters. If it's areas, centimeters squared, etc. Okay? Just one thing to point out here. People weren't reading that this is a square. It says somewhere, yeah, ABCD is a square. That means as long as I know one of the sides, I know them all, okay? We need to know how long this side is, but we're told the area is 14. But because this is a triangle, I won't do 14 divided by 4, right? I need to double it because it's base times height divided by 2 would give me 14. So if I hadn't divided by 2, it would be double that, which is 28 divided by 4. So meaning each side is 7. All the sides, because it's a square, are 7. Now, it asks for the area of the whole shape. So the square will be 7 times 7. The triangle, you already know the area. Add them together. Okay, any more I want to talk about in here? No, same thing here, guys. It's a square. If you read it, it's a square. Some were just missing that it's a square, so all the sides are the same. You need to know the height, obviously, of the triangle, and then you can work at the area. Okay, let's get on to some circles, see how long I've got left in this video. 2 minutes. So we're going to only get this area section done, then we're going to do a third video on this for Friday. A trapezium on, and what's the area of the trapezium? We're missing something though, aren't we? We're missing this. Well, we can get that, can't we, if we know the area is 91. And once we've got that, we can, use our trapezium, which again, we can copy from the front. Top, bottom, height. Yeah, but get the X. Using the area there. Fabulous. Let's get on to same sort of thing. Trapezium on top of a thing. Could split the trapezium into a rectangle and a triangle. Probably not worth it. Go for it. Right, circle. Let's do 1 or 2 with circles. So, the area of the shaded region. You find out that this is a square. Yeah, ABCD is a square. The only measurement I'm given that this is 4.2. But if that is 4.2, that is 4.2. So the square has a length of 8.4. So the area of the square is 8.4 times 8.4. Okay. The area of the circle is pi 3.14 times the radius, not the diameter, the radius squared. However, if to work out the shaded area, the only bit of the circle I'm actually interested in is the bit there. So actually what I need to do in the end is half my area, half my circle area, and take the half a circle away